Hi everyone, welcome to my YouTube channel. So today my topic for this video is the our sentiment analyzer model deployment on the AWS cloud. So here basically we are deploying our model from our local system to the AWS cloud. In the previous video you see we deploy our AWS like our sentiment analyzer model onto the local systems, and in the previous video you see we created one training pipeline, then we pickle the models and then deploy those models with the help of Flask API on the local server. And here code is the same. We are deploying the same model onto the cloud. So let me proceed. So before proceed further, I will show you one thing. In the previous video, you see like our APIs. Our APIs is taking few seconds to return the response on the runtimes while generating the prediction on the runtime. So basically we fix those issues, and basically we define the loading of our model on the global levels. You can see here the code as I highlighted is basically we defining the load of models from the pickles on the global level. So once we start our API server, the one time is model is load, and then on the runtimes like the prediction, like the text data is coming to the web UI and then go to the prediction functions, and then the model is already loaded into the memory. So that's the way we fix those like the response time issue. And let me show you before proceed further. So here basically here this is our local deployment, and you can see here like the URL also changed because in the earlier we run our APIs in the debugging board on the local host in the, you can say, in the dev environment. Now we productionize our API, so that's why the URL also changed. And let me show you how this is responding now. So let me entering here. Yeah, here I already enter one, and once you click, you can see here within the millisecond is responding. So here basically we achieve the low latency solutions. So you can see within the millisecond is responding. So let me back to the our framework. So here like the same framework we are going to use for the AWS also. And before proceed further, I have prepared a document for the steps regarding the deployment on the AWS instance and what kind of process we follow. So I have documented all the process, and so I will share those documents also with you after this video. So here are the this is the document to deploy any machine learning model on the AWS instance, or you can say any model. So let me proceed. So here are the steps to deploy any model on the AWS instance. First prerequisite, we required a login credential for the AWS. And AWS also provided a facility to create the free tier accounts. But to create an account on the AWS, we need the credit card, a valid credit card. Then we can easily create our account on the AWS. And like the creation of the account is out of scope for this video. So I am assuming you have, if you have the already have an account, then you just need to go log into the AWS console, then go to the AWS EC2 dashboard, and then select the EC2 Ubuntu instance, and then click on launch button. Let me show you on the AWS console. So this is the EC2 dashboard. So as I mentioned, like we need to go to the EC2 instance, then click on instance. So these are the instances. And as I already deploy my model to the EC2, so this instance is already in the running state. You can see here, this instance is running state. And this is T2 micro because I am also using the free account here. And these are the public DNS and IP. I will explain all things later. So let me go to the steps. So in the step we mentioned, like we click on the launch instance button here. And once we click here, then we go on the launch an instance page here. And then we have the multiple options here. We just need to select server as per our requirement, like AWS also providing the Linux, Ubuntu, Windows, Red Hat, and also the Mac, different kind of servers. But as we are interested into the Ubuntu here for this case study, we select this, and this is also available for the free tier account. You can see here. The next step is we need to create a key pairs. Basically, key pair is required to access this EC2 instance from your local machines. If you lost this key pair, then you can't access the instance. So you need to create key pair from here and then download this key pair to your local machine and then put this key pair to the C driver. It's recommended you can store in any location, but as per the recommendation, you can store this on the C drive. So here, once you click on the launch instance, then this instance is launch. Let me click here. Yeah, it's I have already like the key pair, so I'm selecting existing, and if in case if you don't have key pair, you can create the key pair here. And let me click here, and you can see here like the instance is launching, and now you can see the instance is launched and it's ready to use. So let me back to our process document. So you can see here we create the key pairs, then we store these key pairs into the C drive as per the recommendation. Launch instance, we launch the instance. So once instance is ready, then we what we do, we need to connect those instances through our local machine, because our code, all things on the local machines, and we need to transfer those model and frameworks or API frameworks, all things on to the AWS instance. So this is the command to access our EC2 instance from the local machine by using the SSH. And where we get this command, so here basically, once this is the instance, we start, and then we click on the connect button. On the connect button, you can see here, we get this command. We just need to copy this command and then open its CMD on the local systems, and then we can easily access this. So in the next step, you can also see here, like we need to go back to the local system, then open the CMD and then run this command. And now we can connect to our AWS instance. And here this one is the CMD. By using this, I'm connecting to this EC2 instance. And let me get back to the steps. So now we have the instance is ready. Now we need to add some security inbound rules. First, we need to create a security group, and then we need to add those security group to the EC2 instance to access our model from anywhere in the world. So here are the inbound rules, like these are the types we need to provide while creating the inbound rule, and these are the protocol, then the port range. So these are then the source. And let me show you this on the AWS. So this is the instance we created, and by default it's created with the launch wizard, and we can create a security group from here. We provide the names of the security group, then description, then add the inbound rules. And as I explained you in this PPT here, these are the inbound rule to create a instance so that we can access those instances from anywhere. And let me move further. So now our EC2 instance is running, and we just need to add this newly created security group to our EC2 instance. So here are the steps. Let me show you on the AWS. So first select the EC2 instance, then click on the action, select the networking, and then change security. In the change security, you can change your group from existing security group to the new group. And now your instance is ready and is accessible all over the world. Anyone can access your application from anywhere. So this is the steps we just follow. And now we need to open another CMDs, and then we need to go to the key pair directories. So, and then run these commands to transfer our data, for example, the pickle models and the API frameworks, all things from local instance to the AWS. So let me show you here. Here, basically, I'm also using the same command. You can see here my AWS key here in this directory. I'm going to this directory to the CMD and then running this command SCP for secure copy of data from our local server to the AWS server. You can see here all data is transferred, and it will take a few minutes to transfer the data. And once your data is transferred, then we need to go back to our previous SSH terminal, those also running. So as I already showed you, this is the terminal. And in this terminal, first we need to set up the environment to run our AI models, our machine learning model. First things is we need to set up the environments, like we need pandas, we need sklearn, we need pickles, all libraries. So before that, we need to run these commands. Basically, we need to add these information into the source list of nano file. And these are the process or steps to add this information into the nano file. then run this command and then install the pip3 here. And after that, check the pip3 version. So those all things through this SSH terminal. And once the pip3 is installed, then our life is going to easy, because we regularly use the pip3 into our Windows servers or different servers to installation of different packages. So you just need to install these packages. As in this case study, we are using the Flask API, NLTK, Jopley, sklearn, NumPy, Pandas, and also take care of the sklearn version. You can see here 1.0.2. And once you install these things, now our instance is ready. Our data is on the AWS. All the framework environment setup is done. Frameworks already available on the AWS. Now we need to move to the frameworks. So here is the ls command to check the framework structures on the our EC2 instance. And then go to the framework folder. Sentiment analysis is our root folder for the framework. And then run this Python 3 sentiment analyzer engine py5. So once you run this file, then our API is going to live. Our model is going to live in this REST API, and we can access this model from anywhere. You can see here, our model is live here. And let me show you how we can access this one. So on the EC2 instance, let me go to the description. So basically this one, the EC2 instance on which we deploy the model. And here are the, you can see here public DNS, one option this, and second one is public IP. Either we can use the public DNS address, or either we can use the IP address, public IP address to access our models. And let me show you on the browser also. Here are the, this is the public DNS address, and this is the public IP address. And here also you can see, let me check any rating live. So here I'm going to IMDb website and copy this rating. Oh, I think it's already copied. And let's check the sentiment. You can see here within the millisecond it's responding. It's also achieving the low latency. And let me go back. Let me try again. You can see here within the millisecond it's responding. And same for the public IP also. Let's here we are accessing our model to the public IP, and then click on the sentiment button. Okay, you can see here it's also responding within the millisecond. So now you can see here our instance is ready, and you can access this from anywhere. And these are the dashboards. You can monitor the performance of your EC2 instance. In case of any issues, you can directly monitor all operations from here, like the CPU utilizations, disk operation, anything you can monitor from here. And so now our instance is ready and it's accessible from anywhere in the world. And let me back to our framework. So let me conclude this video and also this case study, as this is the last video for this case study. So in this case study, we start with our IMDb datasets. We download those datasets from the Kaggle, and then we do the data pre-processing. In the data pre-processing, we do the text cleanings, we remove the special characters and lowercase, also the stop code remove, all things. Then we do the EDAs. In the EDA, we use the word cloud. We check the frequencies of the word, and then the length of the words, and the character in the words, character length. So this kind of different hack we use during our EDAs also. And then we do the EDA on the unigram, bigram, trigrams. And after the EDA, we move to the feature engineering. Then we do the feature engineering by using the TF, IDF vectorizer, count vectorizer. And also we check the feature importance with the help of logistic regression. Then we check the coefficient score and to check the weightage of particular features. And after that, we also tried choice case to select the 2,000 and then 5,000 features during our feature engineering. And after that, we move to the model evaluations. And in the model evaluation, we also do the hyperparameter tunings. And then we select the base model as a logistic regression. And then we do one thing, we prepare a training pipeline with logistic regression. And we also evaluate the performance of training pipelines by using the multiple matrices, as I explained during our evaluation phase. And then we use the Shapley and the line to explain the predictions on the global and on the local level. Basically, on the Shapley, we explain the marginal contribution of the features on the global levels, and we also use the lines to check the feature impact on the local levels, and we also see how we can handle the false positive, how we can handle false negative, how the impact is changed if we remove one features, as I explained during the line session. If we remove the awful word, then what's the impact on the overall predictions, how we tackle the false positive. And after that, we prepare the final pipelines or for deployment of our model. Then we deploy our model on the local server. And once our local server is running, then we achieve the low latency system, low latency solutions. And then we deploy the same model onto the clouds. As in this video, we see we deploy the cloud, and I also prepare the document to make sure anyone can deploy their model onto the cloud by follow the same steps without any issue, without any time consuming. So there's all the steps we follow this in these case studies. And if you face any issue during any stage in this case study, you can directly comment on my video, and you can also contact me on the LinkedIn, and I will provide all possible supports, no problem. And I will share all the code on my GitHub profiles, and then provide the link into the video. You can directly download all the code available on the GitHub, no issue. And so in case of final outcome from this case study, because in the starting of our case study, our objective for the learners who like the freshers who want to start their careers into the data science, or the experience who want to transit their career from the other domain to the data science domains. So in this case study, my objective is giving them the idea how we can approach any data science problem, how we can work in the industry and any data science problem, how we can think while working in any data science project, how we do the data pre-processing, feature engineering, what is the use of feature engineering, how we can use different hacks to fix the accuracies challenges, how we can explain our prediction to our stakeholders. And in case if anyone want explanation why the particular prediction is generated, then I showcase all the things in this particular case studies, so that anyone can get idea how the things working in the industry. So now, like any learners, if follow this case study, can deploy a small model onto the AWS. First, like prepare any model into the text in any text classification data. Similar type of process you can follow, like pre-processing or feature engineering step change project to project, but like the process would be the same. If you work on any text classification data, you can use the same process for the pre-processing, feature engineering, model selection, evaluation, and then deploy your model to the AWS cloud. So, and due to the time constraint, you see like we select the base model as a logistic regression. And if the learners has the times, they can use the same code, and you can try with the assemble techniques during the hyperparameter tuning to change the hyperparameters. And if you achieve the accuracies more than the logistic regression, then you can deploy your model also. And I will also provide you the cloud support, no problem, so that you can deploy your model on the AWS, no issue. And further, so as I promised in the starting of this case studies, like we had the optimal solution, because our solution is responding within the millisecond. On the runtime, user is getting the response through our APIs within the millisecond. So that's the low latency solution. And so as promised, I deliver the optimal solutions, like response within the second. Second thing's explainable. So as I explained through the Shapley, through the lines, so you can easily explain this solution to anyone. So as per the goals we achieve, like we deliver the optimal solution, explainable solutions. So that's the outcome from this case study. And further, I'm receiving a lot of messages from the students on the LinkedIn profile or from the freshers. They want informations like a lot of queries related to the Python into the data science, what kind of Pythons, like what level of Python they require to work into the industry in data science. So after this case study, I'm preparing a playlist for the Python, and I will share those playlists also, so that the learners or the freshers can start their career easily into the data science, because Python is the prerequisite, is the very first step to land into the data science industry. So thank you for watching this video, and please like and subscribe my channel, and thank you. Have a good day.